So in this section, we will go to the coding part and we will go through an overview on creating a simple state graph. The main idea behind this tutorial or exercise is that to share with you and to showcase what's happening along the pathway or along the workflow. The code will be easy and it will be easy to implement it, especially if these days with vibe coding. But the main purpose is to show you what is happening. I'm personally using Spider, which is something I prefer, but you can do this exercise with any of the other IDEs like VS Code or Jupyter, and even if you want to do vibe coding with Cursor and the other extensions in VS Code. Let me start first by importing the libraries. So I will first import LangChain OpenAI. I won't be using it, but I want to import it to allow you or to show you how we will utilize later on in future tutorials the LLM models. Also imported the other libraries and loaded the environment variables. Now, starting with or writing a class which will represent the state, which will hold details or information about the state at each node when traversing the workflow in the LangGraph. So, in this exercise, let's assume we have a chatbot or a simple chatbot that we want to suggest personalized or we want to suggest business names based on the user input. So we will have three components or three variables within our state. The first one is the user input, which is the prompt. We will mimic the prompt. We won't be actually running the LLM ourselves in this exercise, but we will mimic it. The second one is the suggestions, and the third one is filtering out. The third variable will hold out the filtered business names, so removing the ones which are not available. So now creating another variable, which is another list. Here I'm creating or I'm putting the functions. You can see in state graphs, I used the state variable. I've used the state instance or the application state in the parameters. Here, as I said, I'm mimicking the approach. So I'm not sending the data to the LLM, assuming that when this node is invoked, it suggests the following and returns that and updates the state with the following variables. The same thing goes with checking availability. So here I will just put two names as being taken or two business names as being taken. But before delving further with this, let's assume what we will do is that we will have the start node, and then underneath we will have the generate suggestions node, and then check availability, and then the end node. It's just a simple state graph in this exercise. So let me put here the business names which are taken. Then I'm keeping only the available business names before returning back the available business names key value pair within this node. Now let's initialize the language model, although it's not going to be used in our exercise. So building the graph, that's what we do. We give the state variable, the state or the application state as a parameter, then adding the nodes, highlighting how to use the following functions, add node, and later on adding add edges. Okay, so now I want to compile the graph. These are the nodes and the edges that I want to be doing. I want to compile the graph. I'll be just adding builder.compile without giving any parameters at this stage. Initializing the initial state by as a dictionary. This is when I said mimicking the prompt, and then nothing in the suggestions yet, and nothing in the available business names. Now executing through the function invoke. And that will be it. I will save the file, and then I will run it. I will run it and I will show you the variables. So now, after saving the files, I will run it in Spider. And you can see the variables in here that were created. But let me show you the results in here. So when I print it, you will be able to see that these are the suggestions and these are the available business names because I mentioned or I mimicked that agentic AI and MCP were unavailable. So this tutorial is just to show you or to showcase how things gets done in a simple way with a state graph in LangGraphs.